All right, let's move on now to the next rule regarding a power of a function. Say that we have a function f of x that is raised to some power n. This looks like your ordinary power rule if f of x was just an x. What do you do now that there's a function in there? Well, the outer part will become very similar to the power rule. You bring that n to the front and subtract 1 from the exponent. Then you need to multiply by the derivative of whatever's inside the brackets. So this rule is part of a broader set of rules under the category chain rule, and we will cover the chain rule in a subsequent video. Let's look at 4 examples using this power of a function rule. In this first example, we see that we have a quantity here, 2x plus 5 raised to the power of 3. So the power of a function rule simply says that we take that 3 and bring it down, and then subtract 1 from the exponent, so 3 minus 1, so 2, and then take the derivative of whatever's inside the bracket. Now pay attention from your teacher if you have to simplify. In this case, the questions will all be simplified since the multiplications are very easy to perform. And that's your final answer there. Let's take a look at some increasingly difficult examples. Hopefully you find something here that will help you out in those tougher situations. So in this next example, we have a quantity that's raised to the power of 8. So to find that derivative, we have the 1/4, which we'll just leave alone for a second. There's the 8. Now we're going to raise this quantity here to the power of 7. So I'll just do some copying and pasting. And then we take the derivative of whatever is inside the brackets. In this case, we have 18x plus 5. We can simplify a little bit further by just multiplying the 1/4 and the 8 together, leaving us with a 2. That answer is more than sufficient and looks pretty good. Time to move on to the next one. Here we have a situation where the original function does not look like a power because we're dealing with the square root. However, you should recall, based on earlier videos and your exponent laws, that square root is simply a power of 1/2. Now we can take that rule and do the following. Let's just copy and paste here. Okay, so we're going to take the 1/2 and bring it to the front like that. And then we'll do 1/2 minus 1, which is negative 1/2. And then take the derivative of whatever's inside the brackets, which in this case is 7. Some simplification can occur here. We can see here that the 10 and the 1/2 simplify to become 5. Furthermore, we have a 7 here, and 5 times 7 is 35. And in that final step, we can bring the negative exponent down and make it a denominator as such. So what I'll do here is I'll divide by the square root of 7x plus 3. And there you have it. And let's take a look at one final example where we have an exponent that ultimately becomes negative, as we can rewrite the original function here as x squared plus 5 to the negative 4, of course, multiplied by 3 in the front. If we bring down the negative 4, we would have negative 4 times positive 3, which is negative 12. And then we can subtract 1 from the exponent to get negative 5. We take the derivative of whatever's in the brackets, which in this case is 2x. Okay, so let's take a look here in this final step, see if we can do this all kind of in a compact way. I'll do negative 12 times 2x, so that's negative 24x. And then this quantity here, I'll bring it down to the denominator and make the exponent positive. And there you have it.